Okay, so now what is the highest point and what is the lowest? Negative 4. 4? That's my absolute max. And what's my absolute min?
1 negative 3.
1 negative 3. Do you understand it or no? Yes? It's like doing this. Right? Looking at the graph from there to there. What's the highest point? What's the lowest point? Super easy? Maybe? I hope so. Try the next one. Look at between negative 4 and 5 and let's see if you can figure them out. Negative 4, that's right here, and 5 is all the way over here. So what would be the point at negative 4?
Well, they're the same.
At negative 1, right?
Absolutely.
What would be the point at 5? 4. So if I'm looking at the graph only in that interval, what would be my absolute max and what would be my absolute min?
Oh, what if they're the same value?
What if they're the same value? Good question.
Do you write them
Do we pick the one with the highest x?
both? No.
No, we're looking for the highest value and the lowest value, right?
But
We're
these-
really looking at the y's. The x is just where it happens, or like when it happens.
Yeah, they wouldn't.
Yeah, let's put both. What's the big deal? So what would they be? Negative 1, 4, and 5, 4? Okay, what would my absolute min be?
Negative 3, negative 4.
Negative 3, negative 4. Kindergarten stuff? Were either of those relative maximums or minimums? Which ones were relative maximums? Negative 1, 4? Why? It is a killer clown.
Because the graph changes from increasing to
Because the function changes from increasing to decreasing. There was a question like that on your test yesterday, right? Where you had to justify why I had a maximum or a minimum based off of not because of the derivative, but also because of the original function values. So you had to go to that table and you had to pay attention to the y values and see what was happening. Were they decreasing or were they increasing, right? Or were they changing from decreasing to increasing? And that's how you had to justify your answer. Okay? You remember that one or no?
Yeah.
Yes? Okay, cool. What is the next one asking for? Between where and where?
Negative 2 and 6.
Let's do it quick. Negative 2 and 6. So what would be my absolute max and my absolute min? Where are my values at? 0. And over here we're at what? 5? My absolute maximum would be what? 6, 5? That's how tall I wish I was. And what would my absolute min be?
Negative 2, 0.
Negative 2, 0, that's the lowest in that interval? Beautiful. Super easy? Alright. So the next question says, when the domain is restricted to a particular closed interval, at what 3 places could the absolute extrema exist? What could you think of? Where are the 3 places where I could have an absolute extrema? The highest point and the lowest point. We've kind of done some examples already.
At the ends of the even.
So absolute extrema could exist. Very good. At endpoints, that's one of them. So endpoints of the interval, right? that was one place where they happened, right? Like here it happened at the endpoint. Here it also happened at the endpoint. Where else could they happen?
Relative maximum.
They could occur at a relative max or a relative min, right? In this case, it would be where the derivative was what?
Undefined.
Undefined. Over here, it would be where the derivative was equal to 0. So what would you think the other two places could be? If I say relative max or min, that's kind of implying that that could occur
At a critical number.
at a critical number, which would be where the first derivative was
Zero.
equal to 0 or
Defined.
undefined. So that's where the 3 come from. Okay, at an endpoint where the first derivative equals to 0 or where the first derivative is undefined. We can actually write it as 2. We could just say, right, endpoints at an interval or critical number. Do you understand?
Yeah.
Yes? What do you want me to write?
Critical number.
Critical number? Or you want me to put relative max or min?
Critical number.
Critical number?
Yeah.
So we'll have to change this from 3 to what? 2, but it's still actually 3, right?
Yeah.
And what are critical numbers, in case you forgot? F prime of x equals to 0 or undefined. Beautiful? Alright. So, we come into this theorem here, the extreme value theorem. I'm going to ask you a question. Do you think that we'll always have a maximum or a minimum? Absolute max or absolute minimum? All the time.
No.
Whatever I draw, will it always have a highest point and a lowest point? No?
I draw a linear. Exactly.
If I draw points, I can't have the highest point and the lowest point.
The linear?
If I draw a line, it won't have an absolute max or an absolute min.
No.
What if it's a horizontal line?
Yeah.
Let's see. This is 5, this is 0, and this is 4. I'm going to draw a horizontal line from there to there.
No.
What's the absolute maximum?
4.
4. What's the absolute minimum?
4.
4. Did it have an absolute max and an absolute minimum?
Yeah.
Yeah?
But what is like?
What if it's linear?
Linear doesn't have.
Is that a function?
Linear is a function.
Like what's that?
Yeah,
Yeah.
Yeah.
Oh, I mean exactly.
I mean, if you have endpoints, but what if it's just a regular
It's going
function?
for.
What if it's going forever?
Yeah. Y equals X. Then you wouldn't have that.
Then I wouldn't?
As long as you get
Infinity and negative infinity? So that means that there has to be kind of a little constraint, right?
Yeah.
So what would we have to say? That it has to be on what? On a closed interval, right? Because it has to occur at the endpoint, so we can't say open interval. So we're kind of putting all the things that we need for this particular theorem. What else has to be true? What do you notice about these two examples that we did here and these other two examples that we did up here? They were what? Starts with a C. Continuous, okay? So that's another thing that has to be true. Right? The function has to be continuous in order for us to say that there will be at least one absolute max and one absolute min. If it's not continuous, then you can't. It's not guaranteed. Okay? So let's write this theorem here. It's very important that you remember it, because if they ask you to find absolute extrema, you always have to check for continuity first. If it's not continuous, you don't even find it. You will say no absolute extrema, or EBT does not apply. Cool? So, if f of x is continuous on the closed interval from a to b, okay, then f of x must have at least one absolute max and one absolute min on that interval from A to B, a closed interval. Okay? So before I can say that it truly will have at least one absolute or absolute max or min, I have to check that the function must be what? Continuous. If it's not continuous in that interval, then it's not guaranteed that there will be at least one max or one min. Okay? Where are places where a function may not be continuous at? At a hole, and how do I find holes? That's if I have like a rational function and
Common factor.
common factor, right? Okay, where else? At a vertical asymptote, how do I find vertical asymptote?
The denominator goes 0.
Where the denominator of a fraction equals to 0? Okay. What if I had like a square root function? Where would that not be continuous at?
From
When
the
the
where it
inside equals
starts
negative.
and
So like, let's say I have the square root of x. Where's the square root of x not continuous?
When x is negative.
Yeah, when x is negative. Right?
From negative infinity to 0?
yeah.
Is 0 included?
No.
Okay, so let me change it. Let me say, when is the square root of x continuous? In this one, it would be when x is greater than? Just greater than 0?
Greater than or
Can equal to 0?
Can.
It can?
Yes.
Oh, okay. So it would not be continuous in the other interval, right? What if I had this, the square root of x plus 5? Where would that be continuous? So that way if I know where it is continuous, then I technically know where it's not continuous, right?
It's greater than -5. So greater than
So it's wherever this inside is greater than or equal to what? To 0, and if I solve that, I get x's have to be greater than or equal to what? -5, okay? So that's another skill that you need to be able to do. You need to be able to see something and interpret when it would be continuous to know if that function is continuous in that given interval. Okay?
Is it continuous at the endpoint for the?
Yeah.
So like a,
That's where we have that gray area, that discussion, remember?
oh, okay.
That math purists, some people believe that it isn't, and some people believe that it is because of the limit, right?
Yeah,
Remember we had that?
yeah,
Yeah.
The square root function? Okay. So yeah. Do we understand? Good?
Yeah.
Alright. Which other one do you think we might have to watch out for? You can't think of it right now. Okay, it'll come out later in the notes. All of these will. Rational? We kind of mentioned that one already.
Exponential.
Yeah.
There's another theorem that I want to write in here that isn't here, and it's called Fermat's theorem.
That's exponential.
Yeah, Fermat. You know that guy?
Log
For,
function.
what letter? Yeah, is it for?
Fer, F-E-R.
N or M?
M.
M?
Fermat's theorem.
I heard math for.
Well, listen to my words if you don't understand my letters.
I can't, it's,
We don't speak
we just
English.
wanted to make sure.
Okay, good job. So Fermat's theorem, what it says is if f of x, it kind of reinstates what we said up here. If f of x is continuous on the closed interval AB, then absolute extrema must occur at a critical number or an endpoint. Okay? Kind of reiterates what's up here, but it's an actual theorem. When you have kids, your reflexes get pretty fast. Sometimes they're gonna fall and you gotta catch them.
Or like
Do
our
you
video.
though?
Can you take the wheel?
Bad reflex.
Oh, look, that's my kid.
Alright, are we good?
He's having fun. Wait, let's just figure out.
So later on what I'm gonna do is I'm gonna get some books that talk about mathematicians and And you guys will have to do some research over them. After the AP test, you know, so that's all we're gonna do is projects. Okay. We do pen project, we're gonna do a mathematician project, all this fun stuff.
Sure, sir, for the-
Shirts, yeah, we gotta start thinking of designs,
Right.
okay?
Oh, the one that
Right to someone.
Definition.
Oh, yeah, the definition of focus.
Definition of focus, that'll be good.
Yeah.
What
Yeah,
is
we put
it?
that on there.
Yeah.
Wait, did you hear me? He does all the time before we scream.
What is it?
Like he mumbles before he screams.
Alright, so let's do it, real quick.
Wait, what's the
Little top part. What kind of a function is this? This is a what? Starts with a P.
Polynomial.
Polynomial. So are polynomials continuous everywhere? Yes, okay, great. So to determine the intervals where f is increasing or decreasing, how do I do that? We should be experts at that. We just took a test. Sine line, which one? First derivative. Let's go. Quick, quick, quick. What's the first derivative? Boom, boom, boom.
Negative 3x squared minus 12x.
Faster. You're going too slow. Negative 3x squared minus 12x minus 9. Good. Then I have to find my critical numbers.
Factor out a negative.
So set it equal to 0. Take out a negative 3. What's left over? Plus 3. Come on, factor it, factor it. Let's go. Do the wheel. X plus